Hi everyone. So I've just redrawn this diagram so that we can take a look at it a little bit more closely and bigger. First of all, because we see that BA extends to O and CD extends to O as well, we know that these two triangles, OAD and OBC, are similar triangles, which means that all their sides have a common ratio. Now, we're only told about the measurements of two sides to start off with, AD and BC. So we can find their ratio, and we'll know that that same ratio applies to all the sides between those two triangles. So 4 over 6, we can express a ratio as a fraction, is equal to a ratio of 2 over 3. So I know that the ratio of the lengths of the sides of the smaller triangle is 2/3 of the lengths of the sides of the larger triangles. Now, in order to do this question, I'm going to draw an imaginary line that's going to be perpendicular to BC and also AD starting at O. So that's perpendicular right there. So that means that these are right angles. So I've essentially just created a few right triangles here, and we'll see how that will help us to solve this question. I'm just going to erase this so that I have more space to work. Now we're going to have to use our imaginations here to solve this question because we're not really given any other measurements, so we have to create our own. So first of all, I'm going to call the height of this large triangle here, I'm going to call that H. So this entire measurement here is going to be called H. Now, in terms of H, what are the measures of this piece here and this piece here? Well, I happen to know that a measure in the smaller triangle is 2/3 of the measure in the large triangle. So if the height of the large triangle is H, then the height of the smaller triangle must be 2/3 of H. And that leaves just 1/3 of H for this bottom here, which is the height of the trapezoid ABCD. Okay. Now we can look at the areas that we're being asked about. If you remember how we find the area of a trapezoid, so I'm going to say area trap. The way that we find an area of a trapezoid is by finding the average of the two parallel sides and then multiplying by the height. So the average of the two parallel sides will be found by adding 4 and 6, dividing by 2, and then we'll be multiplying by the height, which is 1/3 of H. So 4 plus 6 divided by 2 gives us 5. So 5 times 1/3 of H, and that gives us 5 over 3H. Okay, let's leave that for now. And now we're going to find the area of the triangle, the small triangle OAD, because that's what we're being asked to compare. And the area of the triangle, as we know, is base times height divided by 2. The base is 4 centimeters. The height is 2 over 3H. And we're going to divide by 2. So first I've got 8 over 3H, and I have to divide that by 2, so I'm just going to multiply by half instead, and that will give me 8H over 6. So I've got the area of my triangle, and I've got the area of my trapezoid. Now, we're going to find the ratio as a fraction. So I'm looking at the area of a triangle over the area of the trapezoid. And that's going to be equal to 8H over 6 over 5h over 3. And we don't like to divide a fraction by a fraction, so I'm going to flip the bottom one and multiply. So instead I'll say 8h over 6 times 3 over 5h. And now there are some things that I can cancel out. So I can get rid of the h on the top and the bottom. And now I've got 24 over 30, which I can simplify down to dividing both by 6, 4 over 5. And if we turn that into a decimal, it will give us 0.8. So you can leave it in fraction form, but the answer key has it in decimal form, so either works. And that is the ratio of the area of the triangle to the area of the trapezoid.